I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. As you can see next to me here, I've now got all of the framing for Temptress stood up in the strongback. Everything's been CNC beveled on the machine, and now I'm starting to land some of the timbers and see the results of that work that I've undertaken to date. So this video is going to be about this process to get this last handful of frames stood up, but also I really want to highlight exactly why I've done this process, how and why I'm utilising CNC to get me moved forwards massively in this early stage of the build. The CNC work on this boat build is largely done now, so this boat is by no means an entirely CNC done boat, but this has built me some fantastic foundations that are going to make huge time savings and really push forward the project from here onwards as all of the handwork now begins. So let's get cracking with putting some legs on the final few frames, and I'll show you how I get these stood up and aligned in the strongback. So there are a handful of frames that still need a little bit of work before I can get them placed on the strongback system and start to get them into the boat. So the first thing I need to do is to create some legs to stand those up. These are just ripped from 100mm wide sections of particle board, and I'm using MDF for this. You'll see in just a second that I've also decided to slightly reinforce each of the legs, and that's got me some really good benefits for rigidity when standing them up. So we've got a pile of ripped strips of particle board there, and then we are upstairs to get the frames back onto the construction table again. So throughout this build I've been utilising these holes that run through the frames. Initially they go into this board and they help me to globally locate each of the individual components, but once the frame is finished those holes remain in place, and they then help me to locate the entire frame either on the CNC machine if I'm beveling it, or back on this construction table as you can see me doing here, so that I'm able to transpose the position of various different other things back onto the frames. In this instance you can see that the strongback legs here are going up against two large metal dowels which position the legs vertically and also correctly space them to match the width of the internal faces of my strongback. So those get screwed to the frame to position them. Again, using those dowels to position their width. And now you can see that I'm using a straight edge on the other two dowels that are within the board to transpose waterline 1 onto those legs. Now this is going to be my global reference for height for every single frame within the construction, and all of the frames positions on this board are relative to their position within the boat. So when I transfer the waterline, everything ends up coming out at the correct height. So that's the face of the legs screwed onto the frame and then the waterline transposed. Next up, I'm reinforcing these legs, so to ensure that there's no flex or deviation in these when they're standing up with quite a bit of weight under them, I've decided to create right angle legs here. So I've got a slightly smaller strip of particle board milled to be nice and flat on the table saw, and then I'm gluing this at 90 degrees to the main face of the leg that fits against the frame. So this is going to give me a really rigid and strong leg, nice and accurate for setup in the strongback system. So these all get glued and screwed, and then we're on to getting the lasers ready to go to get things set up downstairs. Now I've opted to use two different coloured lasers here, and actually that turned out to be a really good decision to make, because it gives me a really clear indication of perhaps which laser I'm stood in front of, because there's a lot of shadow casting that goes on when you're messing around with clamps and you're standing around with frames. So that makes a really clear visual reference to follow. And the two lasers positioned at either end of the boat also just help me to get really good coverage on all of these legs throughout the whole setup. As I say, there is quite a lot of potential for casting shadows with clamp handles, with legs, and getting a laser line on every position throughout the boat can be a bit tricky, but this worked out really well with two. So I've just got them stuck onto the metal mezzanine floor legs within my workshop, and then they're leveled to match each other. So we've now got legs on all the frames, so it's just a case of dropping those in one by one, and you can see that waterline 1 mark there that gets transposed from the construction table. So the frames are positioned on that construction table with their global height reference within the boat. That line is transposed onto the legs, and then when we get into the strongback assembly, a laser level fired through there picks up that common plane throughout the boat, and this helps me to get frames not only at the correct height but also square as well, because we're leveling this on both sides of the legs. That means that I've got that frame nice and square and vertical within the setup, but also at the correct height. Frame 9 is slightly different, so this is an angled frame. It sits at 10 degrees within the boat because this forms the back of the rear seat, and it also forms the forward end of the engine bay. So it's got an angled line on that one, and it's a little bit more complex to place, but actually worked out quite nicely. You can see there the nice high contrast between the two laser lines, which works really well. Once I've got everything set up, we're going to start to do some checks to just reference how well this system works, and you'll kind of see the benefits of using this method. And we can already start to see some benefits there. We look at frame 9 that's sat at its 10-degree angle. You can immediately see how those pre-shaped CNC cutouts are looking to be at the correct angle. So we've got that bevel on the bottom there, and then we've got bevels throughout all the topside battens, the shear clamp cutouts, and the chine logs as well. So as I mentioned, those holes through the frame, they help me to initially place and build the frames on the frame construction table to position parts. They then help me to replace that frame back on the construction table and transpose lines from it. But they're also helping me to place the completed frames back onto the CNC machine. So you can see I've run an operation here that drills all of those holes. Now these aren't at their global height within the boat, they're slightly compressed to make sure that I can fit every frame on this board within the footprint of my machine. But you can see that those dowels go into the same location hole, and they allow me to reference this frame with respect to the origin of the machine program that's written to shape them. So you can see I've got a square cut frame here. All of the sections are at 90 degrees and they're sized to the largest size of the bevel, the way that you would normally size boat frames, and then you would normally do this work that I'm doing now once they're actually in the assembly. Then you can see I'm running a program which cuts all of those notches, and it actually shapes the bevel on this frame in a two-sided operation. So this gets cut on one side, then it gets flipped and it gets relocated on the same dowels and then cut on the second side. And you can see some of those angled cutouts there. The reason it's done on a two-sided operation is that you can't necessarily access these cutouts effectively from entirely one side because of the angle that they come through each of the frames. Now, what's this actually going to get me within setup? Well, this massively changes the way in which I can actually build this boat. Because I've taken all of this information from within a highly accurate 3D CAD model, I know that all of those cutouts and bevel angles and rolling bevels, any position throughout the boat, are exactly right on these frames on a per frame basis. That's normally information that you would simply not have within building a boat. In actual fact, what you would normally do is stand up your square frames, and then when you let in all of your battens and chines and shear clamp by eye, using the manual method, that's actually a stage in the process at which you can then get rid of any little tiny errors within positioning or sizing of the frames. So you're effectively going to use the letting in of those timbers to kind of fair the hull and make sure that things are right. Because I'm actually doing this before I'm standing the frames up, and I know that these sizes are dimensionally correct, it's really changing the way in which I can build things. And it means I've got a lot more references when it comes to error checking, to positioning parts, and just to making sure that everything's right. Normally when you set up a boat like this, you would probably have a waterline like what I've got, maybe 2 or 3 water lines depending on the design. You would definitely have a center line, but those might well be your only references that you have. Whereas I've got references on every single frame now that is a known true bevel angle at any given point. I know that the chine angles are correct. I know that the keel angle is correct for the cutouts. I also know that the whole bottom for every frame is correct and is the correct roll in bevel at each stage. So I can utilize any number of different checks here when it comes to making sure that that frame is correct with its position. And that really allows me a huge amount more verification at this early setup of the boat, and that is just going to prevent me from being tripped up by any potential errors throughout the rest of the process. So the next stage to undertake is to just start putting some timbers in place and to see the results of what we get, see how things are lining up, see how things look with regards to fairness, and yeah, see if the timbers fit. So I need a couple of timbers in order to be able to start landing these on my framing. I've got a topside batten here. I'm making the topside battens from Siberian larch, the same timber that I used for the two main stringers that are going to run through the boat. These have a small 1/4 inch radius cut on the two internal faces, and that's just going to allow them to sit into those notches that have been cut in the frames really nice and neatly. And when it comes to seeing this visually on the inside of the boat, it's also going to give a really nice soft edge, which is going to finish and seal nicely when we get to that stage. So I'm just using the handheld router to cut a couple of little radiuses on the inside of some of those timbers. These will of course get scarfed into longer lengths when we actually install them, but right now I'm just doing some early tests to kind of see how things fit and land and how all of this is beginning to work. So I'm going to pick up a few references where I can and see what's going on with the framing in the boat, and just try and do a second verification of that laser line, just make sure that everything really is where it should be. So I've got a clamp on the timber aft there that's just helping me with a bit more leverage to twist that into place on frame 13 towards the back of the boat, and then you can see the landing of that in that notch, really nice seating there throughout those frames, and that's really landing very nicely straight out the gate. See another good landing there. And then when we get to frame 9, little indication that something may not be right with frame 9 here. So you can see how that notch is just a little bit too low on frame 9. And that's a first sign that something may not be right with frame 9. Of course, if you've built boats before, you will know that when you see something like that, it could be frame 9 that's low, but it could be frame 10 and 8 that are too high. So we've got to get to the bottom of why that's happening, and we'll do that very shortly. So very quick, another verification is just to drop a timber onto the bottom of the boat and see if we've got a nice fair curvature and a nice landing to that. I'm also going to drop a timber into the keel notches, and you can see I've got one in place there already in the aft section of the boat where we've got a slightly thicker timber section, and then that's going to get me up to the correct height so that all these notches land for all the frames that then run forward. And you can see immediately how nicely that is landing all throughout those keel notches, so that's looking pretty damn good. But when we get to frame 9, as you'll see again, we're looking a little bit low. So that is pretty good actually, because that's telling the same story as the topside batten notch, which indicates that frame 9 might be a little bit low. Just going to draw that timber forwards, and then we're going to roll it out over the top of the stem which is placed, and see how that lands. And you can see here, just as I pull that down, beautiful landing of that, and That's looking really good, and we've got a nice fair curve. These things are a little bit difficult sometimes to show on camera, but that is a beautiful fair curve right down the length of the keel there. So something's going on with frame 9. Need to do a little bit of investigation there, and to be honest, I'm not really surprised because of the fact that frame 9 is at an angle. The way in which the waterline is transposed is a little bit more tricky, and it's very specific about which face of the frame that line is transposed. So it's transposed from the control face, which is the face of the bulkhead, and also the face of the strong back leg, but there is potential for error there. So what I've done is I've dropped into the CAD model. I've got a height for the keel notch at frame 9 station, height that is referenced from the waterline. So you can see what I'm doing here is I'm dropping a tape measure down, and I'm just looking for the end of that tape measure until I just see it break that laser line. You can just see the red or the green line just shining on right on the edge of the head of the tape measure, and then I'm measuring the height of the keel notch and comparing it to what I've got in the CAD model. Now, just to make sure that I'm not checking that entirely on frame 9, and as I said, it could be that frame 9's low, it could be that frame 8 and 10 are high. We've got to get to the bottom of exactly where that error falls here. So I've done that measurement on frame 9. I'm now doing it on frame 10 to see just how accurate that is, and then I can write a comparison of all of those figures against the CAD model and see what's going on. The beauty of having known, accurate, beveled, notched frames within this boat is that I can pretty much go into the CAD model, I can pick up a dimension from anything to anything, and I can reference that to what I'm actually seeing here. So that allows me to measure the height to the top of the stem tip that you can see. I'm using the same process here, just referencing down to that waterline to check that my stem is in the correct height within the whole setup. So the results of my findings, written down a handful of reference things to check here. Sure enough, frame 9 is around about 2 millimeters high of where it should be at the keel, so that is out of the tolerance we're aiming for. We are aiming for a tolerance of a millimeter accuracy. F10, 11 and 12 is 2 millimeters out as well, but as you can see, F10 and F11 were absolutely bang on, so that's really good. Done a couple of other reference checks as well, just wanted to check the height of the stem top, and then all the forward frames, so a little bit of adjustment needed there. And what I actually found was that also the forward frames weren't initially vertical. Understandable, they're just stood up on legs at the moment, and if you remember, we had that slight roll off there, which I corrected a little bit, but probably didn't get quite close enough. But in any case, vertical checks for these have definitely got to be done. And I've now got those placed. You can see that I'm starting to do a little bit more reinforcement of the frames. So basically what I'm doing going forwards now is I'm going to work through the boat one frame at a time. I'm going to do a handful of different checks for all the various different things I can measure. The keel notch height is a nice easy one to do. Obviously we've got the waterline that's getting us pretty bang on close and actually within a millimeter's accuracy for most frames, but we just want to do some checks. I'm then making sure that everything's vertical, and as I get it vertical, I'm then doing some bracing. So you can see I've got a 45-degree brace here on frame 1, just making sure that's correct. When I'm also verifying the heights, I'm putting in these little stop blocks here. So these are just glued to the frame leg, and that's going to allow me to remove that frame and then replace it there when I need to, and make sure that I'm going to go back in exactly the correct position that it should be. So as I sign off each frame, I'm doing that. And then for these frames, because I've got this angled 90-degree section on each of the legs, I can screw into the outer face of the strong back, and that is going to help me to get the frame nice and vertical and have a good bit of brace in there. You can see there's next to no movement in that frame. I'm going to put some diagonals on some of the frames just for additional bracing, so that when we start to load this up, we get it a lot firmer. But frame 1's got that. Of course, the stem jig also ties that into the strong back. So we're starting to get a huge amount of rigidity in this. And as I confirm each of the measurements, we're basically looking to lock that in and just get that finalized. All of these frames will come back out one at a time. We've still got to epoxy coat these before we do the final glue up. So this initial stage really is a kind of big trial dry fit. I want to just land a load of these timbers here, make sure that I'm definitely happy with the position of everything. As I mentioned, lock it in and confirm it with those little stop blocks and screwing in the legs. As and when I'm happy, get rid of the clamps and go over to screws. Once I'm happy with all that, we'll then be able to start doing a full glue up. But it's looking good. Next job on the list is just to get frame 9 shifted up and get this little error here worked out. Okay, so frame 9, done a little bit more investigation and some measurements. Actually, what I think is happening here is that this is leaning forwards, and thinking about it, that makes perfect sense. This is a really heavy frame, and I've just got it sat on its individual straight legs at the moment. This is definitely needing bracing there, and I've just, to be honest, I've quite loosely placed these frames for now just to get them somewhere close and for me to start. But what I did was a measurement from here to here. I've got this frame vertical, and this is quite a bit too far this way, so it needs to come back up. That is inadvertently going to make the keel notch height correct, probably. So that has made me think that actually what I need to do is just work through the boat, get everything perfectly vertical, get it braced, make sure that it's all properly where it is, rather than just quickly loosely placed, and then start to land some timbers and see how things are getting on. So I've done all that in the forward end of the boat. We'll jump up there and we'll start to land some timbers into the stem and see what's going on. So you can see I've got angled braces on frame 4, incredibly rigid. The minute you put that angle brace in there, everything just firms up massively. So that's tying 4 and 3 together, nice and low down there. I've got this angled brace on frame 1, tying that in. I've got these little stops done on the first 5 frames. And then I've got the screws into the outside of the strong back as well. So the whole front end, I've now definitely firmed these up. So I've double checked the keel notch heights. We've obviously got waterline 1 on the laser, which is gone off. And yeah, keel notch heights are correct on all these. Frames are definitely vertical on all these. So what I'm going to do is shift these topside battens up forward, pull them into the forward end of the boat and see what we're getting there. Might get a chine in place as well and just bring that in, try and land that into the stem. So let's get cracking with that. So there's a timber in the chine landing for you. Obviously I've not notched this properly into the stem yet, but you look down that line, that's pretty damn good. See how we land on each frame. Ever so slightly kicked up, but you can see where that timber's going to sit. Again with 4, it's going to pull into there beautifully. See how nice and fair that line is. Same with this topside batten that I've brought in up forward. These have got a load of edge set on them because of the flare in the bow. As this timber comes over, it's wanting to bend upwards like this. You can just about see it from this direction actually. You can see how much that bends along its widest edge. It will just about do it actually with this larch. Clamps aren't the ideal way to do this. When we actually install these, I'll be using screws into the frames with some big washers on, and that'll just help reduce this where we've got a bit of twist in the timber. This will actually pull in correctly. But as an initial trial, it's landing really well. Again, I've not got this. This is going to land up into this notch here in the stem. But I'm pretty pleased with that. In the forward end, that's pretty awesome actually. So you can see what this process has allowed me to achieve. As soon as I got the frame stood up in the strongback, I'm able to start offering up these timbers, checking the lines to see how fair they are, and I'm landing them straight into notches that are pre-cut. I've got so many different references that I can use to just verify the position of things and start putting timbers in straight away. That is, I've certainly never done that on a boat before. That's a pretty big leap forward, I would say, in the speed in which this boat is going to be built when it comes to actually kind of pushing the button and getting things glued in down the line. So I'm really looking forward to getting to that stage. Normally what you'd be doing with boats at this stage is, of course, all of these frames would still be square. So as you offer these timbers in, you'd be then using that information to just put the bevel onto your frame at that particular stage. You'd be cutting these notches in and checking that these battens are all fair as you go, and it's a massively time consuming process cutting all of these notches in for all the topside battens, the chine landings. Everything is it's going to take a long time if you're doing this manually, but that's just the way that wooden boats are built, really. Certainly boats like this up until now, with utilizing these new kind of practices. So I really hope this is going to change the way in which we can build boats like this in the future. And I'm still trying to get my head around how many hours this is potentially going to knock out of a build, but it's anything from 500 to 1,000 hours maybe this could take out the build. Not just with kind of saving the time of cutting the notches and beveling, but just the way in which the whole project is going to flow, because everything's going to be much fairer from the start and it's going to carry on throughout the rest of the process. So we'll see that throughout this project, and I hope I'll continue to illustrate the benefits of using CNC at this early stage. As I mentioned, I'm near enough done with the CNC machine now. This is all going to be hand work from here on out, and I'm actually looking forward to that, because I do prefer it to listening to that thing scream away in the corner of the room. So that's as far as we're going with this for now. What I'm going to do is I'm going to roll out this sort of verification, checking process throughout all the rest of the frames. I'm going to get some more bracing done just to make sure that everything's really where it needs to be, because when you start springing in timbers like this, it's a lot of force on the whole system, and that's the reason that the strong back needs to be bonded down. Everything needs to be so well braced. One thing I did want to mention, a couple of people have kind of mentioned in the past about putting their strong back on wheels and building the boat on that. I can't stress enough, do not try and build this on wheels. I know the kind of drive to be able to make it movable, and you might be a bit tight on space, but you will never ever achieve any kind of accuracy. You've seen the kind of level I've gone to with this, with the string line and getting it bonded and getting all this stuff placed. The minute you put this thing on wheels, you would be constantly fighting changes as you spring those timbers in. So bonding to the floor, definitely my recommendation if you want to build one of these. So that's where we're at. We're looking good. It's starting to become more boat shaped by the day. Hope you guys are enjoying the series, and thank you very much for watching. Thank you patrons as well for your additional support. Massively appreciate that. I will catch you guys in the next one, where we'll probably start dropping the big stringers in next, the 2 big laminations. So I'll see you then. Cheers.